Welcome, dear explorers of the cosmos, to another journey with Earth with nature. Let's take a quiet moment to settle into the vastness of the universe, where questions outnumber answers and wonder is our guide. Tonight, we're diving into the heart of one of nature's most enigmatic creations: black holes. From their fiery birth in the collapse of massive stars to their mysterious evaporation in the distant future, we'll unravel the story of these cosmic giants. Picture yourself standing at the edge of the unknown, gazing into a void that defies comprehension. What lies at the center of a black hole? What secrets does gravity guard so fiercely? Let's embark on this slow, thoughtful voyage together, peeling back layers of space-time with curiosity as our compass. As we begin, I invite you to breathe deeply and let your imagination stretch across the stars. We're not just observing, we're feeling the pull of the infinite. So, come along as we trace the life of a black hole, from its first violent heartbeat to its final, whispered farewell. Let's dive straight into the cosmic forge where these dark wonders are born, exploring the science, the theories, and the profound mysteries that make black holes a testament to the universe's untamed beauty. Our journey starts with the life of a massive star, one destined for a fate beyond imagination, a fate shaped by the relentless hand of gravity. Imagine a star many times the mass of our Sun, burning fiercely, its core a cauldron of nuclear fire. For millions of years, it holds itself together, balancing the inward crush of gravity with the outward push of fusion. But nothing lasts forever in the cosmic dance. When the fuel runs dry, when the core can no longer fight, gravity wins. The star collapses under its own weight, shrinking in a cataclysmic implosion that shakes the fabric of space itself. This is the birth of a black hole, a moment so violent, so profound, that it warps reality around it. What must it feel like to witness such a transformation? To see a star's light snuffed out, replaced by an abyss. Pause for a moment and let that sink in. The scale is staggering, isn't it? Modern telescopes like the Hubble and the Event Horizon Telescope have given us glimpses of these events, capturing the shadows of black holes against the glow of surrounding matter. These tools of science and technology reveal not just images, but stories. Stories of creation and destruction written in light and shadow. And as we peer into these distant realms, we're reminded of how small yet connected we are to the grand tapestry of the universe. This collapse isn't just an end. It's a beginning. It forms an event horizon, a boundary beyond which nothing, not even light, can escape. Think of it as a cosmic veil, hiding the true nature of what lies within. What do you imagine is beyond that veil? Is it a point of infinite density, a singularity where the laws of physics break down? Or something else entirely, something our minds can't yet grasp? As we linger on this thought, let's consider the photon sphere, a ghostly orbit where light itself can circle the black hole, trapped in a delicate balance. It's a place where the universe seems to hold its breath, and so do we. Science tells us that black holes are not just static voids. They spin, they grow, they merge. Observations from projects like LIGO have detected the ripples in space-time, gravitational waves, caused by black hole collisions, proving that these dark giants are dynamic, interacting with each other across vast distances. Isn't it awe-inspiring to think that we can hear the echoes of such events billions of years after they happen? Let this wonder settle into your mind as we prepare to step closer to the heart of the mystery. We're not just exploring black holes. We're exploring the limits of what it means to understand the cosmos. So, as we move forward, let's carry this sense of cosmic wonder with us, letting it guide our thoughts and questions about the universe's deepest secrets. Now, let's linger in the fiery cradle of a black hole's birth, where the universe's most massive stars meet their dramatic end. Imagine a star, a titan of the cosmos, with a mass 20, 30, even 100 times that of our Sun. Its life is a blaze of glory, fusing hydrogen into helium, then heavier elements, layer by layer, until its core is a dense heart of iron. But iron is the end of the line. Fusion here no longer releases energy. It consumes it. The star's delicate balance shatters. Gravity, ever patient, seizes its moment, and in a fraction of a second, the core collapses. This isn't just a gentle fall. It's a violent implosion, a supernova explosion that outshines entire galaxies for a fleeting moment. What remains is a black hole, a scar on space-time where gravity reigns supreme. Can you picture the sheer force of this event, the raw power that rips through the fabric of reality? Let's pause to feel the weight of that transformation. Science, through tools like X-ray observatories such as Chandra, has shown us the remnants of these explosions, the glowing debris and the shadowy voids left behind. These observations aren't just data. They're windows into the universe's most extreme processes. A black hole's birth is a reminder of nature's duality, creation through destruction. As the star collapses beyond a critical point, it forms the event horizon, that invisible boundary marking the point of no return. Think of it as a cosmic one-way door. Step through, and you're lost to the outside world forever. What must time and space feel like on the other side? General relativity, Einstein's masterpiece, tells us that within this horizon, the rules we know twist and bend. Time slows, stretches, and perhaps even stops as we approach the center. This is where the concept of a singularity emerges, a point of infinite density where our understanding of physics falters. But is it real, or just a placeholder for something we can't yet describe? Modern theories in quantum gravity, like string theory, suggest the singularity might not exist at all, replaced by a realm of exotic physics we're only beginning to explore. Isn't it humbling to think that even with all our technology, from supercomputers modeling black hole formation to radio telescopes capturing their silhouettes, we're still at the edge of knowing? Let's take a moment to reflect on this. How does it feel to stand at the brink of such a mystery, where every answer births a dozen new questions? As we ponder the birth of black holes, we also see their connection to the broader cosmos. They're not isolated. They shape galaxies, influence star formation, and anchor cosmic structures. Observations of supermassive black holes at the centers of galaxies, like Sagittarius A** in our own Milky Way, reveal their role as gravitational engines driving cosmic evolution. Imagine the intricate dance of stars and gas swirling around these giants, a ballet choreographed by gravity itself. This interplay, captured by cutting-edge instruments, shows us that black holes are not just destroyers but builders in their own right. So, as we move deeper into their story, let's carry this image of balance: birth from death, order from chaos. Let's step beyond the event horizon in our minds, not with fear, but with a sense of exoplanet mysteries, the same curiosity that drives us to seek new worlds and new truths. Let's slow our pace now and hover at the edge of a black hole, at the boundary known as the event horizon. This is no ordinary line. It's a frontier where the universe draws a curtain over its deepest secrets. Imagine standing just outside this invisible wall. Light, information, everything that crosses it is lost to us forever. It's as if the black hole whispers, "You may look, but you may not know." Can you feel the eerie stillness of this threshold? The way it seems to swallow not just matter but the very concept of escape. Take a breath and let that sink in. Science describes the event horizon as the point where gravity's pull becomes so intense that even light, traveling at 186,000 miles per second, cannot break free. This isn't just theory. It's been visualized through the groundbreaking work of the Event Horizon Telescope, which in 2019 captured the first image of a black hole's shadow in the galaxy M87. That blurry, fiery ring wasn't just a picture. It was proof of a boundary we've long imagined but never seen. Now, let's drift a little further out to the photon sphere, a ghostly orbit where light itself can circle the black hole endlessly, trapped in a perfect, fragile balance. Picture beams of light bending, looping, creating a halo of trapped radiance. What must it look like to see the universe reflected infinitely in such a sphere, a mirror of space-time warped by gravity's hand? This phenomenon, predicted by Einstein's equations, shows us how black holes don't just consume, they distort and reshape reality around them. Advanced simulations using supercomputers help us visualize these effects, rendering the bizarre paths light takes as it grazes the edge of oblivion. Isn't it astonishing that we can model such otherworldly physics from the comfort of our planet? Let's pause to marvel at this blend of nature and human ingenuity. The event horizon and photon sphere are more than scientific curiosities. They're gateways to deeper questions about the nature of reality. What happens to time here? Near the event horizon, time dilation, a consequence of relativity, stretches moments into eternities. If you were to approach this boundary, in thought of course, an outside observer would see your clock slow, your every move crawl, until you seem frozen at the edge forever. Yet, from your perspective, you'd cross without noticing a change. How does that paradox make you feel, knowing time itself bends to gravity's will? Reflect on this for a moment. This strange behavior isn't just a quirk. It's a clue to the black hole's core, a hint at the mysteries locked within. As we linger here, let's also think about how black holes connect to broader cosmic stories. They're not solitary. Their influence ripples outward, shaping the space around them. Gravitational lensing, where a black hole's gravity bends light from distant objects, acts like a natural telescope, revealing far-off galaxies we might otherwise never see. NASA's studies of these effects show us that black holes are not just voids but lenses into the past, amplifying the universe's history. Isn't that a beautiful thought? That even in their darkness, they help us see more light. This interplay of shadow and illumination reminds us of the interconnectedness of all things, from the smallest atom to the largest galactic structure. So, as we prepare to venture closer to the enigmatic center, let's carry this sense of planetary science facts with us, grounding our wonder in the tangible discoveries of today while reaching for the unknowns of tomorrow. What do you think lies beyond this cosmic curtain? Is it a singularity, a point of infinite mystery, or something our science hasn't yet dreamed of? Let these questions simmer as we transition to the heart of the black hole, where theories clash and imagination takes flight. Our journey through space-time continues, each step a brushstroke on the canvas of cosmic wonder. Now, let's take a daring step beyond the event horizon, into the uncharted depths of a black hole, where the concept of a singularity awaits. Imagine a place, or perhaps not a place at all, where all the mass of a collapsed star is compressed into an infinitely small point, a speck of infinite density where the laws of physics as we know them cease to apply. Can you fathom such a concept, a spot where space and time themselves seem to break? Let's pause here, not to rush through, but to truly feel the weight of this idea. A singularity is not something we can observe directly. It's a prediction born from Einstein's general relativity, a mathematical endpoint where equations scream undefined. But does it truly exist? Or is it a signpost telling us our understanding is incomplete? Modern physics grapples with this question through theories like quantum gravity and string theory, which suggest that at the smallest scales, the universe might resist such infinite collapse. Perhaps, instead of a singularity, there's a realm of exotic matter or a structure we can't yet describe. Isn't it thrilling to think that the heart of a black hole might hold the key to unifying quantum mechanics and gravity, two pillars of science that stubbornly refuse to align? Reflect on this for a moment. How does it feel to stand at the edge of human knowledge, peering into a void that challenges everything we think we know? Science and technology offer us tools to probe these mysteries indirectly. Supercomputers simulate black hole interiors, while experiments at particle accelerators like the Large Hadron Collider search for clues about the fundamental nature of reality. These endeavors remind us that even if we can't see the singularity, we can chase its shadow through data and imagination. Let's consider another layer. Black holes aren't uniform. Spinning black holes, described by the Kerr solution in relativity, might have a ring-shaped singularity, a rotating anomaly that could, in theory, connect to other regions of spacetime or even other universes. This idea of wormholes or cosmic bridges sparks the imagination. Could a black hole's core be a gateway rather than an end? While this remains speculative, it's grounded in the mathematics of physics, a testament to how science often dances with the fantastical. Picture yourself floating in this theoretical space, where reality twists into possibilities beyond comprehension. What would you hope to find if such a portal existed? As we dwell on these exoplanet mysteries, let's also connect the singularity to the broader universe. Black holes, whether tiny or supermassive, are thought to play a role in the cosmos's entropy, its measure of disorder. Stephen Hawking's work suggests that black holes aren't eternal prisons. They leak information and energy through a process we'll explore soon. This ties their cores to the universe's ultimate fate, a story of balance between creation and dissolution. Observations of black holes in distant quasars, powered by supermassive cores, show us their influence on cosmic evolution, shaping galaxies over billions of years. Isn't it humbling to think that something so small in concept, a singularity, could ripple across such vast scales? Let's take a quiet moment to absorb this interconnectedness, from the infinitesimal to the infinite. Now, let's turn our attention to the quiet, almost poetic end of a black hole's life, a process so subtle yet profound that it challenges our very notion of permanence. Imagine a black hole, once thought to be an eternal prison of gravity, slowly fading away, not with a bang, but with a whisper. This is the realm of Hawking radiation, a concept born from the brilliant mind of Stephen Hawking in the 1970s. Picture the black hole's edge, the event horizon, not as a perfect barrier but as a place where quantum effects play a strange game. Virtual particles popping in and out of existence can split apart, one falling into the black hole, the other escaping as real energy. This escaping particle is Hawking radiation, a faint glow that means the black hole is losing mass, bit by infinitesimal bit. Can you imagine something so powerful, so seemingly invincible, dissolving over eons into nothingness? Let's pause here to absorb the beauty of this idea. The idea that even black holes are not forever. Science tells us this process is agonizingly slow. For a stellar mass black hole, it would take longer than the current age of the universe to evaporate completely. But for tiny, hypothetical primordial black holes, formed in the early universe, this evaporation could be happening now, ending in a final burst of energy. While we can't directly observe Hawking radiation with current technology due to its faintness, experiments like those at CERN probe the quantum principles behind it, and future detectors might one day catch a glimpse of this cosmic fade. Isn't it remarkable to think that quantum mechanics, the science of the very small, could unravel the fate of something as colossal as a black hole? Reflect for a moment on this interplay of scales, how the tiniest fluctuations might dictate the destiny of the mightiest objects. As we linger on this concept, let's explore its deeper implications. Hawking radiation suggests that black holes aren't just destroyers. They return energy to the universe, perhaps even information about what they once consumed. This ties into the information paradox, a puzzle about whether the data swallowed by a black hole is truly lost or somehow encoded in the radiation. Cutting-edge theories in quantum information science are tackling this mystery, using mathematical models to suggest that nothing is ever truly gone. Imagine the black hole as a cosmic library, its contents slowly leaked back to the universe over unimaginable timescales. What stories might that radiation tell if we could read it? This process of evaporation also connects black holes to the ultimate fate of the cosmos. In the deep future, trillions of years from now, when stars have burned out and galaxies have dimmed, black holes might be the last structures standing, slowly dissolving through Hawking radiation until only a cold, empty void remains. Observations of cosmic microwave background radiation give us hints about the universe's long-term trajectory, supporting these predictions. Isn't it humbling to think of black holes as both creators and final witnesses to the universe's story? Let's take a quiet moment to feel this vast timeline, to imagine ourselves as fleeting sparks in a narrative that stretches beyond comprehension. This journey through exoplanet mysteries and black hole life cycles shows us the impermanence woven into even the most enduring phenomena. What does this slow fade teach us about resilience and change? How does it mirror the cycles we see in nature here on Earth? As we prepare to wrap up our exploration, let's hold on to this sense of cosmic wonder, seeing black holes not as endpoints but as part of an endless transformation. Our final reflections will tie these threads together, connecting the birth, life, and death of black holes to our own place in the universe. Let's carry this gentle awe with us as we transition to a broader view, one that invites us to marvel at the interconnectedness of all things. As we near the end of our journey through the enigmatic world of black holes, let's step back and gaze at the broader tapestry of the universe, where these cosmic giants play a role far beyond their dark boundaries. Imagine the universe as a vast ocean, with black holes as deep whirlpools, unseen forces that shape the currents of stars, galaxies, and perhaps even life itself. From their violent births in stellar collapse to their slow evaporation through Hawking radiation, black holes are not just isolated mysteries. They're threads in the fabric of cosmic evolution. Can you feel the interconnectedness, the way their gravity tugs at the very structure of space-time, influencing everything from galactic spirals to the potential for habitable worlds? Let's pause to let this sense of unity wash over us, to feel our own small place within this grand design. Science reveals that supermassive black holes, lurking at the centers of galaxies like our Milky Way, act as anchors, regulating star formation through jets of energy that can stretch thousands of light-years. Observations from the James Webb Space Telescope are uncovering how these giants formed in the early universe, suggesting they may have seeded the first galaxies. Isn't it astonishing to think that the same forces that create black holes also nurture the conditions for planets, and perhaps life, to emerge? Reflect on this for a moment. How does it feel to know that destruction and creation are so intertwined, even on the largest scales? Black holes also challenge us to rethink time and reality. Their extreme gravity, bending light and slowing time, offers a glimpse into the relativity that governs our universe. Experiments with atomic clocks and GPS technology show us time dilation in action, a faint echo of what happens near a black hole's event horizon. This connection between the cosmic and the everyday reminds us that the mysteries of black holes aren't distant. They touch the very fabric of our existence. What lessons might black holes hold for us about patience, about the slow unfolding of change? As we ponder these planetary science facts, let's also consider the philosophical weight of black holes. They embody the unknown, the limits of what we can perceive or understand. Yet, through tools like gravitational wave detectors and radio telescopes, humanity pushes those limits, driven by a shared curiosity. The study of black holes isn't just about physics. It's about wonder, about asking questions that may take generations to answer. Picture yourself as part of this quest, standing on Earth, a tiny speck in the cosmos, yet reaching out to grasp the infinite. How does this pursuit of cosmic wonder inspire you to see your own challenges, your own unknowns, in a new light? Let's take a quiet moment to hold this thought, to feel the bridge between the vast and the personal. Black holes also mirror the fragility and resilience of existence. Their eventual evaporation through Hawking radiation shows that even the mightiest structures are transient, part of a cycle that spans eons. This impermanence connects to the story of Earth, a planet that thrives amid constant change. Studies of exoplanets using missions like Kepler and TESS remind us that worlds like ours might orbit stars influenced by distant black holes, their fates shaped by the same gravity that binds the cosmos. Isn't it humbling to see ourselves as part of this delicate balance? A fleeting moment in a story that began with a big bang and stretches into an unknowable future. As we prepare to close, let's carry this sense of awe and connection with us, seeing black holes not as voids but as symbols of transformation, of the universe's endless capacity to surprise. What do black holes teach us about our own journey, our own capacity to endure and evolve? Let's transition to our final thoughts, weaving together the science, the mystery, and the personal reflections that make this exploration so profound. And so, dear travelers of the cosmos, we come to the end of our gentle journey through the life of black holes, from their explosive births to their quiet evaporation in the deep future. We've stood at the edge of the event horizon, felt the dizzying spin of space-time, and pondered the enigma of singularities. We've listened to the ripples of gravitational waves and marveled at the slow fade of Hawking radiation. Above all, we've connected these dark wonders to the broader story of the universe, a story of creation, destruction, and transformation that includes us all. Can you still feel the pull of that cosmic mystery, the way it draws us to question, to imagine, to wonder? Let's take one last quiet moment to sit with this feeling, to let the vastness of black holes remind us of the beauty in the unknown. Science and technology have been our guides. From the Event Horizon Telescope capturing the shadow of a black hole to LIGO detecting the echoes of their mergers. These tools, built by human hands, extend our reach into realms we can't physically touch, proving that curiosity is a force as powerful as gravity itself. Studies of supermassive black holes with instruments like the Chandra X-ray Observatory reveal their role in shaping galaxies, while quantum theories hint at the secrets of their cores. Isn't it incredible to think that each discovery, each planetary science fact, brings us closer to understanding not just black holes, but the very nature of reality? Reflect on how these advancements mirror our own potential to grow, to push beyond what we thought possible. As we linger in this sense of cosmic wonder, let's also remember the personal connection we've forged. Black holes, with their cycles of birth and death, echo the rhythms of life on Earth. The impermanence, the resilience, the endless interplay of light and shadow. They remind us that even in the darkest voids, there is potential for revelation, for beauty. Imagine carrying this perspective into your daily life, seeing challenges as event horizons, not barriers but boundaries to explore with courage and curiosity. What mysteries in your own world might you approach with the same awe we've felt tonight? Let this thought settle gently, like stardust on a quiet night. Our exploration of exoplanet mysteries and black hole life cycles also ties us to the broader quest for knowledge. Each question we've asked about singularities, about time dilation, about evaporation, connects us to generations of thinkers, from Einstein to Hawking, and to future minds who will build on what we know today. You're part of this legacy, part of the human story reaching for the stars. So, as we close, I invite you to keep this journey alive. If this voyage through the heart of black holes has sparked something in you, please take a moment to like this video. It helps us reach more curious souls eager to explore the cosmos. Subscribe to Earth with Nature for more immersive journeys into the wonders of the universe, from distant exoplanets to the hidden forces shaping our own planet. Your subscription means we can keep crafting these stories, weaving science and wonder into experiences that inspire. And I'd love to hear from you in the comments below. What struck you most about black holes? Do you find their mystery thrilling, humbling, or something else entirely? Share your thoughts, your questions, or even a simple hello. Let's build a community of explorers right